Hi friends, in this video we are going to discuss about how to calculate the current for pure resistive circuit, pure inductive circuit and pure capacitive circuit. Here what is the meaning of pure resistive, pure inductive and pure capacitive circuit means if the circuit consisting of only resistance, then that type of circuit we are calling as purely resistive circuit. And if the circuit consisting of only inductance, then that type of circuit we are calling as purely inductive circuit. And if the circuit consisting of only capacitance, then that type of circuit we are calling as purely capacitive circuit. And we know that in case of purely resistive circuit, the phase angle between the voltage and current is always 0 degrees. And in case of purely inductive circuit, the phase angle between the voltage and current is always minus 90 degrees because of the property of inductor. Inductor is an element which does not allow the sudden changes in current. So because of this particular reason, so there is some difference between the voltage and the current waveform. And here in case of purely inductive circuit, the current lags applied voltage by exactly 90 degrees. So that is the reason why in case of purely inductive circuit, the phase angle between the voltage and current is always minus 90 degrees. But in case of purely capacitive circuit, as per the property of capacitor does not allow the sudden changes in voltages. So because of this property, current leads applied voltage by exactly 90 degrees. That is what? Positive 90 degrees. Leads means positive 90, lags means minus 90. Okay. It means current leads applied voltage by 90 means you will get the theta is equal to plus 90 degrees. Current lags applied voltage by 90 degrees means you will get theta is equal to minus 90 degrees. Okay. Now, if you are going to observing the waveforms of the purely resistive, purely inductive and purely capacitive circuit. So the waveforms are like this. In case of purely resistive circuit, the phase angle between the voltage and current is always 0. And here just you can observe that in case of purely resistive circuit, the voltage waveform and current waveform both are in phase because resistor is an element and it does not store any energy, and also it does not affect, or simply we can say that it allows both the voltage and current at a time. So that is the reason why the current waveform and both the voltage waveform both are allowing at the same time. Okay, so that is the reason why we do not have any phase angle between this voltage and current. So that is the reason why in case of purely resistive circuit, so theta is equal to 0 degrees. Okay. And if you are going to observe the waveforms of this particular purely resistive circuit, so voltage waveform, here V represents the voltage waveform and here I represent the current waveform. It means both voltage and current waveform both are in phase, but here coming to the magnitude of voltage and magnitude of current, so there is a difference in the voltage and current magnitude due to the presence of resistor in the circuit. Okay, so this is about what? Purely resistive circuit. Now coming to the purely inductive circuit, as per the property of inductor, it does not allow the sudden changes in current. So that is the reason why, for example, this is t, time t is equal to 0 seconds. At t is equal to 0 seconds, the voltage waveform is started like this. But here you can observe the current waveform. Current waveform exactly started after 90 degrees. So that is the reason why the phase angle between this voltage and current is 90 degrees, and here current lags applied voltage by 90 means so the theta is equal to minus 90 degrees. And coming to here for pure capacitive circuit, for example, this is, you can assume, for example, theta is equal to 0 seconds. Now for purely capacitive circuit, the phase angle between the voltage and current is 90 degrees, but here current leads applied voltage by 90. That is the reason why theta is equal to plus 90 degrees. Okay. Now, if you are clear with all these important points, then we are going for the calculation of, so current for purely resistive circuit, current for pure inductive circuit, and calculation of current for purely capacitive circuit. Okay. Now we are going to discuss about the current calculation for purely resistive circuit. Now see, so first I am going to starting with the calculation of purely resistive circuit. Now see, so first point is purely or pure resistive circuit. Pure resistive circuit. I am going to consider pure resistive circuit here. Now see here, this one is the purely resistive circuit. I am going to consider the value of applied voltage as well as the value of resistor also. For example, I am taking the value of resistance R is equal to, for example, 10 ohms, and applied voltage, for example, V is equal to, for example, I am taking, so 10 volts having a angle of 0 degree, and our target is to find the value of total current. Okay, now how to find the value of current? How to find the value of current for pure resistive circuit? Now you can observe that what is the expression of impedance? Impedance is equal to Z is equal to R plus J into XL minus XC. Okay, so this expression is always applicable when resistor, inductor, capacitor all are presented in the circuit. But in the given circuit, we are having only the value of resistor R. So that is the reason why what we are doing, we are simply neglecting the value of XL, we are simply neglecting the value of XC, because we are having only the value of resistor. So that is the reason why we are going to write the impedance for purely resistive circuit is Z is equal to R ohms. So this is the impedance for purely resistive circuit, and we know that Z is equal to R means what is the value of R? We are having R is equal to 10. Now we know that for purely resistive circuit, the phase angle between the voltage and current is 0. So that is the reason why here Z is equal to 10 is the magnitude having an angle of 0 degree, and this is always in ohms. Now this is the value of impedance. Now after getting the value of impedance, what we need to do? We need to find the value of total current. That is IT is equal to Vt divided by Zut. Here Zt means impedance, this one, this is the total impedance. Now here Vt divided by, here Zut means what? Zut means only value of resistor, because we do not have inductor, we do not have capacitor. So here total current IT is equal to, Vt is how much? Vt is given value, V is equal to, so that is 10 having angle of 0 degree divided by the value of resistor is how much? The value of resistor is 10 and having a phase angle of 0 degree for purely resistive circuit. Now here 10 gets cancelled. Here you will get the value of IT is equal to 1, and coming to the calculation of phase angle, always we need to simplify like this. Okay, just see here, we are having the 0 degree in the numerator and we are having the 0 degree in the denominator. Now when we are going for the calculation of this phase angle, always we need to subtract. And for example, if suppose you are having the negative sign for denominator angle, then when it will comes to the numerator, it will becomes plus. So like this, depending upon the sign of the angle, you can easily find the value of phase angle. Now from this we can say that, so IT is equal to, so 10 by 10, 1 means, so 1 having an angle of 0 degree. So this is the value of current for purely resistive circuit, and you can observe that here we are getting the value of 0 degree because this is a purely resistive circuit. In purely resistive circuit, the value of phase angle is always 0 degree. So here 0 degree we are getting. Okay, now this is the calculation of current for purely resistive circuit. Now coming to the purely inductive circuit. Now second one is, so pure inductive circuit. So pure inductive circuit. Now we know that pure inductive means if the circuit consisting of only inductance, then the type of circuits we are calling as purely inductive. Now what I am doing, I am going to consider the value of, so instead of L I am directly taking XL, because why I am taking the value of XL directly means just I am giving the information regarding the purely resistive and purely inductive and purely capacitive circuit. But when you are going for the analysis of AC circuits, instead of resistance we need to calculate the value of what? XL, because always we need to calculate the value of XL and XC for the analysis of AC circuits. That means what? For example, in the problem you have the value of L is equal to, for example, 10 millihenries, then it is mandatory to convert from L to XL, because after converting XL only, it is possible to analyze this particular circuit. So that's why directly I am taking the value of XL is equal to 10 ohms instead of taking the value of inductance. Okay. Now here V is equal to, for example, V is equal to I am taking, so 100 having a angle of 0, and here for example I is the current which is flowing in the circuit. Now what we need to do, first you can observe that in the circuit we are having only the value of L. It means what? How we can take the value of ZL? So now we can take the value of Z only. Z is equal to R plus J into XL minus XC. This is the actual expression of a impedance for RLC circuit. But in the problem or in the purely inductive circuit, we are having only the value of L, that is inductance. So that is the reason why for purely inductive circuit, the impedance Z is equal to J into XL. Okay. So J into XL, and this is in ohms. I think now you are clear. Okay. Z is equal to J into XL. Now we know that Z is equal to J into XL. XL means how much? 10 ohms. So here 10 ohm is the value of XL. Now Z is equal to 10. Here J means plus 90 degrees. You know about the J operator concept. Okay, instead of J, we can directly place the value of plus 90 degrees. For example, if suppose you are having minus J, then you can directly place minus 90 degrees. So Z is equal to 10 having a angle of plus 90 degrees because we are having the positive J. Okay, so here Z is equal to 10 having an angle of 90 degrees. So this is in ohms. Now you got the value of impedance. Okay, you got the value of impedance. Now go for the calculation of current for purely inductive circuit. Now see here, I am going for the calculation of purely inductive circuit. So what is the formula we are having to calculate the value of total current? So that is IT is equal to VT divided by ZT. Here VT divided by, for purely inductive circuit, the value of ZT is what? J into XL. Okay. Now here IT is equal to VT is how much? In the problem we are having the value of V is equal to, for example, 100 having an angle of 0 degree we are taking. Now instead of V, we can directly substitute 100 having an angle of 0 degree divided by, what is the value of Z here? So Z is JXL. Here the value of JXL is how much? So the value of JXL is 10 having an angle of 90 degrees. Okay. Now if we are going to simplifying this one, you will get 100 divided by 10 coming to the angle 0 degree. Denominator you are having plus 90 means when it comes to the numerator it will becomes minus 90. Okay. Now here IT is equal to 0 gets cancelled. Then you are having the magnitude of 10 and coming to the angle you are getting minus 90 degrees. Okay. So this is the value of current calculation for purely inductive circuits. Okay, and we know that for purely inductive circuit the phase angle is minus 90 degrees. So that is the reason why you got minus 90 degrees here. Okay, now this is the calculation for current of what? Purely inductive circuit. Now coming to the third one, that is the last one, pure capacitive circuit. Okay, so pure capacitive circuit. Here pure capacitive means what? If the circuit consisting of only capacitance, then that type of circuits we are calling as purely capacitive. Now I am going to drawing the circuit for purely capacitive. So here this one, for example, we are considering as C. Then C is equal to, for example, that directly I am taking the value of XC. XC is equal to, for example, I am taking 20 ohms. Here for example V I am taking 200 having a 0 degree, and I is the current which is flowing. Now we know that directly we are having XC, then no need to go for the again calculation of XC, because whenever you are having the value of C directly, then we need to convert into XC. Okay. Now you are having the value of X is equal to 20 ohms. Now here calculation of impedance. Actually Z is equal to R plus J into XL minus XC. So this is the actual expression for impedance. But in this particular purely capacitive circuit, we are having only the value of C. That is the reason why what we need to do for expression of impedance, we can directly take, so here J into minus XC. So this is the expression of impedance for purely capacitive circuit. Okay. Now we know that XC value we are having 20 ohms. Now Z is equal to J into, so minus 20 ohms. Now this is the value of Z, we can also write Z is equal to minus J 20 ohms. Okay, now this is the value of Z clearly. Now find the value of current with the help of Z, that is Vt, It is equal to Vt divided by Z2T. Here Vt divided by Z2T. Z2T means what? So Z2T means only we are having capacitance, means minus Jxc, that is equal to Vt is how much now? Vt is 200 having angle of 0 degree divided by here minus J means minus 90 degrees, Xc is how much? 20. Here minus J means minus 90 degrees I am directly taking. Now total current It is equal to, so 0 gets cancelled and 2 ones are 2 tens are, it means you will get 10 having a angle of 0 degree. This current is in the denominator, when comes to the numerator it will become plus. So here total current It is equal to 10 having an angle of plus 90 degrees. So this is in amperes. Okay, so like this we are going for the calculation of current for purely resistive, purely inductive, purely capacitive circuits. Okay, so thank you so much for watching, and please do subscribe my channel for more updates. Thank you so much.